Hello, good afternoon, good morning, or good evening, depending on where you are in the world when you're listening to this podcast, or indeed watching it on YouTube, because I did notice we are getting 60, 70 hits and views almost straight off the bat. So welcome to our YouTube viewers. My name is Jamie Dobson. I am the host of this podcast, The Cloud Native Attitude, and the founder of Container Solutions. I'm joined by my colleague Ian.
Hi, I'm Ian Mile. I'm a partner at Container Solutions, where I help Jamie solve cloud engineering and strategy problems with our clients.
Well, we help our customers succeed with the cloud. Now today, and the timing is absolutely perfect because KubeCon is happening next week. We're going to be talking about Kubernetes. Now specifically, we're going to be doing three things. My pathetic contribution, my tiny contribution, Ian, is to the name Kubernetes. Where does it come from? And there's actually quite an interesting story behind that. But the second thing we want to talk about is, well, what is Kubernetes? What is an orchestrator? And what was the path to Kubernetes? And Ian, the third thing, as you always say, if AWS is the new Windows, then Kubernetes is the new Linux, right?
Yep, that's right.
So those are the three topics we're going to be covering. Word origins, what are orchestrators, and what is this so-called new Linux? Now, before we do that, we have been getting some feedback from not our listeners, Ian, but from our viewers. Do you know what the feedback's been about?
No, do tell.
Well, the first one was they've spotted Yorkshire tea over my left shoulder.
I can't see it. Oh, there. No, I can't see
You can
it.
see it on the YouTube videos. So for
Yeah.
those people who are listening to the podcast, you won't be able to see this, but over my left shoulder in my man cave is a pot of Yorkshire tea. Now, we try not to be stereotypical as Yorkshire people, but it is true. We all drink Yorkshire tea, and we've all got...
Grown in Yorkshire, no doubt.
It's grown in Yorkshire, yeah, in the fields of Harrogate. The second thing I've been getting questions about is the poster of the Omen, the last Omen behind me. The reason why that poster's behind me is because its release date was the 5th of April, and that's my mum's birthday. And so the poster is a reminder that the devil is always watching. So that's the story of the Omen. And then to anybody who's our age, that's basically me 50, anybody who's about 50 odd, will recognise that those pigs, what are they, Ian? Do you know what they are?
They're the NatWest. Is it NatWest?
It was the NatWest piggies, that's right.
Yeah, didn't you get them as a kid if you've saved up a certain amount in your bank account?
This was correct. So I think if you opened a bank account with NatWest, you got the little baby pig. And then if you managed to get to £1, you got the next pig up. And I think the business pig, that was the daddy pig. If you saved, I don't know, 10 quid, 20 quid, you got the daddy pig. Nobody on North Hull got all of those pigs. Everybody had the baby pig for opening the account, but nobody had any money to put into the account to get the next pigs along. So the story is I was walking past a charity shop a few years ago, and I realised that my only chance of owning all of the NatWest piggies was to buy them all, and they were on sale for £1 each in a charity shop. And I was like, yes, I've scored them.
You cheated.
I cheated. I did cheat.
Oh,
yeah.
Wow. Well, that's the patriarchy for you, isn't it? The biggest and best one is the male one.
It is a bit crazy when you think about it. And it's funny. I'm going to bring that now. I feel sorry for the people listening on the podcast because they can't see. Well, this is 1980s England for you. The daddy is in a bow tie and some sort of black suit. And the mum has got a little ribbon around her blouse and she's carrying a handbag.
There you go.
So there's where the NatWest pig is, and the song went, what was the tune of the song? The piggies are waiting for you, down at the NatWest.
Bonus musical interlude there from Jamie.
I was never much of a musician. Right, should we shut up now and get on with this Kubernetes podcast? Right, okay, so did you know, so you're from London, Ian, and I'm from Hull, and Hull, as you know, or you might not know, was one of the most bombed cities during the Second World War.
Mm-hmm.
And over my right shoulder in Greenwich Park, there's a statue of General James Wolfe. He was the hero of Quebec. They talk about battles not being decisive, but one battle that the British won, led by General Wolfe, switched ownership of Canada from the French to the British. But he died in the battle. So there's lots of things around Greenwich to do with James Wolfe. And I mention this because on the back of that statue, there's huge bullet holes. And the reason is because across the water, it was the London East End. And the German planes would come over the channel, come straight down the boulevard, across Blackheath. They would use the statue of James Wolfe as target practice. And once they were hitting him, they knew they were on a direct run to London's East End, which was the industrial heartland. And then they would deposit their payloads. Now, all around here, there are old ACAC guns. The ACAC guns would fire at the German planes, but they would never actually hit anything. They were mainly used as a morale booster. So the guns were absolutely terrible. This was, in many ways, the so-called firing table issue almost gave birth to computers as we knew it. So theoretically, if you knew the weight of the shell you were firing and the speed or the trajectory of the plane above you, you could quickly look up a firing table if you were the gunner, turn the ACAT gun to the right angle and press fire at the right moment, and the shell would hit the plane at the same time. Anyway, the problem was, as we invented new shells and as the Germans and the other sort of combatants in the war invented new aeroplanes, these firing tables would need to be updated. So they would get sent over to the United States, a place called in Aberdeen, Maryland, a proving station there that they used to test weapons on. The firing tables would come back to the guns. Now, the problem is technology was advancing quicker than they could update the firing tables. So those guns and the firing tables that came with them never actually hit anything.
Release management.
Release management. It was a massive release management problem. And the ENIAC, which was one of the first digital computers, was invented to solve the firing table problem. But actually, by the time they finished building it, the war had already finished. Now, this is the story. Norbert Wiener, he was an American mathematician. He had this idea, well, what happens if you could put a small computing device on a gun that could calculate in real time the speed of the plane, the weight of the bullet, and therefore the trajectory of the gun? And then something amazing dawned on him, that a machine with a basic sense of feedback actually, maybe, could have a rudimentary sense of mind. So all of a sudden, when Norbert Wiener was thinking about these guns, he started to think, wow, maybe computers could be made to think. Well, anyway, the war came to an end and he was flat, stone cold broke. And somebody said, well, we'll pay you to write a book on this new idea of yours. He needed to come up with a name, so of course he raided the Greek and Latin dictionary. He first came up with a name, I think it was, what was it? Angelos, meaning messages from God. But that sounded a little bit, well, too religious. Then he thought of Gubernator. Now, Gubernator was a Latin word, Gubernator, I should say.
Mhm.
Gubernator was a Latin word that in English had become governor. Now, the governor was part of a steam engine that controlled the amount of steam passing through the engine so the damn thing wouldn't blow up. But of course, governor itself then mutated further to mean the boss. So that had a negative connotation. And anyway, luckily for Wiener, he soon discovered that Gubernator was actually a corruption of the Greek. Now, I can't say this in a Greek accent. How's your Greek, Ian? Any good?
Not great. Not great.
Am I going to try to do this at the risk of offending millions of people?
Go on.
Cybernetics. That's my Greek accent. I'm so sorry. Cybernetics was the Greek word that Gubernator was a corruption of. So Wiener anglicised that, Cybernetics, to get to Cybernetics. So the birth of Cybernetics is basically around control and control machines, and that derives from the Cybernetics, which is a Greek word. And if you fully anglicise that, you get Kubernetes, which is, of course, the name of the popular open source orchestrator that we're going to be speaking about today.
Wow. All the way from guns and Quebec. Was it Quebec?
The
Canada.
Battle of Quebec, yeah.
To modern day Kubernetes. Who'd have thought of it?
Well, so James Wolfe was born in Greenwich, you see, so everything's called James Wolfe Street. There's a statue, there's a James Wolfe School. He's buried in the crypt at St Alphy's, which was a beautiful church built by Nicholas Hawksmoor, who was a student of, what's that guy?
Christopher Wren.
Christopher Wren.
Yeah, I studied history, and my special subject was English architecture 1660 to 1720.
Wow.
So Hawksmoor's my architectural pin-up.
Is Hawksmoor got anything to do with the restaurant, the steak restaurant in Canary Wharf?
I don't know, to be honest. I don't know. It's not a common name.
No, you get the feeling it's not common. Right, okay, so that is therefore the origin of the word Kubernetes. So that's a great bit of trivia in the week that KubeCon is about to happen, which brings us, mate, to our very next topic. What the F is an orchestrator? Where did Kubernetes come from?
Well, yeah, you mentioned this before the podcast, and there's so many ways to answer that. And I suppose I'd like to answer it by sort of going back in time a bit. So we've talked about containers.
How far back in time are you going to go? Like wartime?
Well, no, not Jamie Dobson time, but a little bit back, because we had containers in 2015, 14 when Container Solutions started, and we'd had similar concepts before, as we talked about last week. We had apt and tar and so on. With all these encapsulating tools, there was always the problem of how do we deploy them and run them. And as people were using Docker, they realized that they couldn't just use a single container to manage their business manage their business application, and you'd need multiple containers. And so along came very quickly a tool called Docker Compose, which I think was originally called Fig.
Fig was a London-based company. I think Docker ended up buying them, you know.
They did, because I knew one of the founders. He's in the US now. Very smart guy. I think he ended up losing interest in Docker and got into uh, emulators. Was very into emulators.
Right.
Nice guy. Wish I could remember his name. He'll get a shout out, I think, in the notes. Then Fig came along, and Fig was a really practical, quick tool that allowed you to bring different containers up together and manage them as a single unit. And at the same time, not Docker, Google were looking at Docker and thinking, well, they'd obviously they sort of invented containers. That's a whole nother story about how they changed the Linux kernel so that it had this capability to run namespaces, what were called namespaces, but basically make it look like there were multiple machines in one.
And when you say they invented it, do you mean Google or do you mean Docker?
Sorry, I mean Google. Yeah, so Google did a lot of the work in around the early 2000s to allow the Linux kernel to seem to have multiple network stacks in them, multiple file systems, multiple process tables, and so on. And they separated these things out. And to cut a long story short, Google took these innovations by Google and they made it extremely usable for the average engineer by adding things. Well, they added a single command line interface that put all these things together to make it look like a virtual machine. And they also added the Docker file, which pretty much any engineer could grasp very quickly.
It was a plain text file, wasn't it? The Docker file.
Yeah, Docker file was essentially a very simple way of writing a script. It could be reduced to a shell script, essentially.
So we have Docker as a container, and then all of a sudden, logically, people came to the conclusion, well, you can't do much with a single container, I suppose, unless you stick everything in it. But then doesn't that defeat the object of?
Well, that was not considered a good architectural pattern for various reasons, which we talked about, I think, in previous weeks. But it wasn't the way the industry was going. People wanted to have smaller units of deployment and operation. So Google looked at this and said, hang on a second, we do the same thing internally. We have a system, a platform in our business called Borg, which was a way for, I mean, I don't know Borg in detail. I've never worked for Google, but I understand it was essentially Kubernetes running within.
Now, just speaking of Borg, are you a Star Trek fan?
Yes.
And now we're doing weird origins. What is the origin of the word Borg in Star Trek?
I don't know, actually. It's either Bjorn Borg, the tennis player, or it's Cyborg.
So my assumption was always that it was cyborg, that, you know, the Borg are a bunch of cyborgs, but actually it is Bjorn Borg because he was so robotic and so repetitive as a player that the Star Trek creator said, oh, these robots are going to be completely predictable and completely monotonous like Bjorn Borg. And the joke is the reason Bjorn Borg was like a robot is because he was so emotionally explosive as a teenager, he had to learn to control himself. And in learning to control himself, he developed these rhythms that made him actually look the opposite of what he originally was, which is boring.
I'm surprised they didn't call it Lendl then, after the Czech player.
That's right.
He was very robotic. I think more than.
All I remember from Ivan Lendl is the Ivan Lendl Adidas tennis gear that I could definitely not afford, but I was dead jealous of the kids at school who could. It had diamonds on the front of it. Right, okay, that's enough of the 1980s. Back to Google's Borg.
Yeah, so Google had this platform that essentially was a precursor to Kubernetes, and they still use it today. I spoke to someone, when I worked for a bank before, I spoke to someone at GCP who designed the original Borg software and its successor, which I believe is called Omega. And Google did what many software businesses do, which is say, we built this thing, it works, but it's not the way we'd like it to be. We think we can rebuild it better. So they built a new version of Borg, I believe called Omega, and it didn't take in the end. So they backported all the improvements to Omega to Borg.
Oh my God. Okay, so the last time we spoke on this podcast, we were going crazy. In fact, we've been going crazy for this whole podcast because we get frustrated that people focus on the end state, and by forgetting the lessons that you learn on the way to building a system, which is the most important thing, people think they can jump to it. So even Google fell into that trap. They forgot that the lessons they learned whilst building Borg, which then of course became part of the system, and the failures that brought those lessons were forgotten to history, like beaches, like footprints on the damn beach. But then they also made the same mistake and thought, oh, we can build a mega again, and it will be better than what we had before.
That's my understanding, Jamie, but I have to say I'm not a Google insider. I didn't know. Maybe they built this thing as an experiment just to learn the lessons of what they could backport to Borg. But I believe that they wanted everyone to move to this thing, but it was such a mature system, Borg, by this time, that getting all those engineers to move was in itself going to be a massive task. So the more evolutionary approach is the one they ended up having to use. I'm sure Googlers who know more about this could correct us, but that's my understanding what happened. Anyway, the point is they had this system called Borg, and they thought, right, we could rebuild this again, but make it open source. And Google had a lot of soul searching. Also, this is my understanding from what I've heard on Grapevine, they had a lot of soul searching about whether open sourcing it was a good idea, because essentially they were giving away free IP. But the argument was, if we give away Kubernetes, as it ended up being called, if we give away that, then people will have a path to use our cloud platform, because this was the time they wanted to open up their internal platform to the public. So just like with AWS, where they had this internal service and they want to make it public, Google had an internal service Borg or obviously their compute platform, and they wanted to make that public and sell that to the public. So the idea was we build an equivalent of Borg that's public, that's open source. Everyone's going to get around it, and then everyone will have a path to get their workloads off AWS basically and Azure and onto the GCP. And this is one strand of my argument that Kubernetes is the new Linux, because that was exactly the argument of Linux. As long as your software operates against the Linux API, you can run it anywhere. You don't need to run it, you don't need to have a license to run the operating system. You're not locked into Windows. You can run it on whichever distribution of Linux you want. And so another answer to your original question, Jamie, what is an orchestrator, is it's an API for running stuff.
Right.
And
so the thing is, now this is quite unbelievable to me, Ian, but Kubernetes, the open source project, actually only came out 11 years ago. So this is 2014. Google had some sort of app engine, but it was years and years before Google Cloud emerged as a genuine competitor to AWS. What was the interplay between Kubernetes and Google Platform? And were they not worried at the time that, well, if it would drive people to our cloud platform, won't Kubernetes be used to drive traffic to AWS, to Microsoft's Azure platform, which in the end, of course, did happen?
Well, just like Linux, Google Cloud Platform was the second to market, if you like, later to market. So in business in general, if you want to be later to market, you make everything open so that people can move from the incumbent to you. This is why people like Microsoft don't want standards necessarily, or they play fast and loose with standards, so you get locked in. We saw the same thing with databases back in the 80s and 90s. There was a standard, SQL, but Oracle, Informix, SQL Server, they all had their little, well, not so little in some cases, tweaks around that standard, or their own little implementations that meant that it was harder and harder for those businesses that were integrated with those databases to move to another platform. And I mentioned before, I worked for an online gambling company. We used Informix. And our customers would say to us, oh, we want you to use Oracle because Oracle is the industry standard. And we said, fine, that'll be 10 million or whatever it is to do the porting. And they would say, well, how could you justify that? And we said, well, we'll have to work on this and this and this and this. And by the way, your systems might break on a Saturday because we've tested the limits of Informix. We've never tested the limits of Oracle in the same way. Oh, yeah, and you'll need several DBAs, not just one that you need for Informix.
I'm an engineer. Well, I was once upon a time an engineer. Java, crack my fingers. Why would Kubernetes interest me? So I'm going to chuck a web app together. I'm going to have a payment system, a way to log in. I'm going to have some sort of search functionality. And then when I've built that, I'm going to put it in a WAR file, a web archive. I spoke about that with Allard when I last chatted with him. And I'm going to give it to someone in ops. Where does Kubernetes fit into that landscape? And developers loved it. So why would I have loved it when I was still a programmer?
So what you're talking about there is stick it in a WAR file and send it out. Essentially, that's the same model, right? If you're in a completely Java world, WAR files are your unit of communication with other parts of the business, right? As you say, you send your WAR file over and then they just deploy it and then you're kind of done, right? I mean, I'm simplifying massively, but that's basically it. Kubernetes is similar, except that its unit is the container. And what that changes, or one of the things it changes, is that you can use any programming language you want. it doesn't have to run on the JVM. So there was a lot of money before Kubernetes came along. There was a lot of money invested in making the JVM run, or rather, making different programming languages run on the JVM. The theory being that if the JVM is the standard unit of compute now, and if our programming language can run on the JVM, then it can run anywhere, and you can create a WAR file, and suddenly you can integrate it with all the release processes. Operations was maturing in the industry, and people wanted conformity. And what the container did, and what Kubernetes did as a consequence, was that it meant you don't have to write Java anymore. You don't have to write it against the JVM. You can take your existing code and move it to this new platform. So your question again, what's in it for the developer? It's that standardization of deployment, which you don't have in Linux. I mean, unless you count copying a file to the bin folder, which isn't really quite the same. As a developer and as an architect, suddenly there's a lot of things you don't need to worry about so much. You've got a standard platform. You've got a standard way to deploy, although there are different ways to deploy, but from a high level, you simply create your pod, create your service, create your application, and then deploy it. But also things like certificate management. So as an engineer, I might have, oh God, I've got to create certificates for my new app. Right, I need to go to the ops team. I need to send them an email, get them to create some new certs for me. They ask me if it takes a while and they're busy, whatever. All these things would happen. Because you've got a single platform, someone just writes an operator and it detects that a new application has come up and it just automatically creates the certificates for you. As it is with certificates, it's the same with monitoring, with all these non-functional requirements. They can all be taken care of by the common platform. So another way to answer the question, what is an orchestrator? In the context of Kubernetes, it is a way for developers to spend more time just writing software and not writing infrastructure stuff that is common to multiple applications.
Exactly, not worrying too much. Is it true in container orchestrators, and we may as well just take Kubernetes, right, because it is the winner. There were alternatives, but Kubernetes is the winner. Is it true that Kubernetes is the infrastructure that Docker is? So what I'm trying to say is, when containers came out, physical containers, it was a unified box. The dimensions were known, and the ports around the world that succeeded were the ports who adopted containers, because once you had a physical
You're talking about real containers now,
real
Jamie.
container, once
Yeah.
you had a real physical container. By the way, we get emails every week from people trying to buy containers off us. So we could have had a great sideline in selling and wheeling and dealing in physical containers. But once, for example, different ports around the world decided to use containers, then all of a sudden they had standard rails, standard cranes, standard sized ships, and actually the container made that infrastructure possible. And all of a sudden, what used to happen on the side of the dock has now become automated. Is it genuinely true that the metaphor of containers, Docker containers being the container and Kubernetes being all of that surrounding infrastructure, is that true, or is that too far a stretch?
No, I think the metaphor holds up really well, because you could think of things like Argo CD as being the emergent tools that are the rails that allow you to get your container onto the ship, literally shipped. I mean, even the language, the history of the language
But the implication
reflects
is that Kubernetes makes no sense without containers and vice versa.
Well, orchestrators weren't just built around containers. So Mesos was originally built around VMs to orchestrate VMs. And that was for very large scale computing systems. So I think maybe Twitter even still runs on Mesos. I'm not sure. And I think ECS under the hood is a variant of Mesos at least. So yeah, so there's this whole you don't need Kubernetes does not require Docker. In fact, under the hood now it uses OCI containers, which are the industry standard that was built around containers and doesn't require Docker at all. And also, as Adrian mentioned the other week, you can run VMs within containers in pods, within Kubernetes in pods. So there is nothing. Kubernetes is a very abstract idea. It is simply the platform that can run your workloads. And you could even take it further and say that Kubernetes, another way to answer your original question is to say that Kubernetes is actually a series of control loops. So control loops are essentially infinite loops. So this is a traditional paradigm of programming, is that each process is just a continuous loop which runs and detects changes and acts on those changes. Back to your governor.
But that is literally the definition of cybernetics.
Exactly.
Literally, the definition of going back to Norbert Wiener's definition is something happens constantly, and only a change in the environment will make a change in the machine, which will then react to it. So a thermostat is a negative control loop. It keeps the room at a certain temperature, where a nuclear reaction is some sort of positive control loop that feeds into itself.
Yeah, exactly. So I was going to mention the thermostat as the classic example. Kubernetes is essentially a way of running control loops, and the way Kubernetes is organized means that you essentially disturb the universe. You mentioned disturbing the universe the other week, which was actually a line from, I was going to mention it, a line from T.S. Eliot's love song of J. Alfred Prufrock, but we won't go there. But yeah, you essentially disturb the universe. You change the configuration of the Kubernetes system.
Yeah.
Kubernetes detects that change and then goes off and tries to resolve the situation into a new form of stability. It's a very kind of beautiful idea. It's not an original idea. I've mentioned Erlang before. Erlang uses the same kind of concept. That's also a distributed system. But you see the difference between a declarative system where you state the situation you want, and then ghosts in the machine figure out how to change the situation so it's back in a stable state. Yeah, this is what Kubernetes brings.
So Kubernetes is declarative. You say what you want, and it figures out how to get you what you need.
Yes, so Kubernetes is defined using YAML files, so static declarative files, and you can put little bits of, for example, in a pod, you can say, start up with this little bit of shell, which is not declarative, but that's quite a subtlety. If you just take it at the very high level, you have this declarative system, and that declarative system, when changes are made, it's detected, and then it acts on it. And the things that act on it are the intelligence. So that means that the intelligence is hidden away from you, is abstracted away from you, just like with the thermostat. You don't care what the thermostat is doing, you just turn the dial up and down. The intelligence is baked in to the software. So there's a clean separation between what you want to achieve and how it's achieved. And that's another way to look at what Kubernetes is.
So previously we said that Docker did to apt what apt did to tar.
Yep.
What did Kubernetes do something to? What has it displaced? What technology has it booted out the door? What manual process has it sort of displaced in our working lives as computer programmers?
Yeah, so I suppose two things come to mind. One is the manual release process, which I was doing up till 10 years ago, which was take your build artifact, CP it up to a few servers, and then untar it and restart your apps, and you're done, right? So it's replaced that. At a minimum, even if you're doing your Kubernetes releases on the command line, you still have to build Docker artifacts. So there is forced a separation of build and run, which is kind of ironic, really, when you think that we go on about Kubernetes and DevOps, and actually there is a clean separation between build and run. So in theory, you can separate out. Sorry, what was the question? It was building. How did I get to building?
My question is what was Kubernetes displacing? What
was it displacing? Yeah, it also replaced what we call configuration managers. So many people who listen to this podcast will have used Chef, Ansible. There was also Salt. I remember. I don't know what happened.
Something called Salt.
Yeah, I don't know what happened to that. But there were lots of tools which attempted to do a similar thing, to build the rails for delivering your software artifacts to production. And this was before containers. And those tools are becoming less and less used. They're often used in conjunction with Kubernetes. So a lot of people build Kubernetes using, for example, or Chef. But that was very much oriented around a VM-centric view of the world as opposed to a container-centric.
So in the first episode of this podcast, we spoke about Jeff Bezos doing a nutter. Sounds like a great guy, doesn't he? So Jeff Bezos does nutters, and that's where he has a tantrum, and then things therefore consequently happen. One of his nutters was about the time it took to get software into the hands of users. So it became very frustrating for him. Let's say I was, plotting the way I had an idea for one click or a way to store credit card details that would help Amazon's customers spend more money. Now, I don't think Bezos knew what he was talking about at the time, but actually what they ended up inventing was a way to program a whole raft of computers as if you would work on your local machine. And what that does is put you into a state of flow and high productivity. So in a way, it's a very humanistic idea. The quicker feedback you get on what you're working on, the more you get in flow and the bigger your ideas. Is Kubernetes part of that? Does it speed up the creative process as well by making things disappear?
Oh, that's a really good question because I think a lot of engineers get frustrated with Kubernetes.
Right, so it does the opposite.
It can do. It can do. So with any abstraction, you take certain things away, but you add certain things in. So what do I mean by that? Well, with Kubernetes, if you need to worry about certificates, if you need to worry about monitoring, if you need to worry about all these non-functional things, it's great because you say we don't need to worry about any of those things. All we do is build a Docker container or set of Docker containers, and we configure them to run in Kubernetes. Whoever's running the Kubernetes cluster can worry about what they need for sets or what they need for monitoring. So
So yes, so in some ways it helps with the creative process, but in others
yeah,
it actually gets in the way because it puts more
but
obstacles.
But if you're doing a very simple application, and I get this at home all the time, so I write things at home for my home systems, and I think, oh, I should probably use Kubernetes for this because that's what I'm supposed to use, well, it's what I often use at work. But I don't need it. It creates all this overhead that I don't need. I just want to run something. I just want to run a process. And a lot of engineers feel that way. A lot of engineers think, why do I need to write a YAML file to basically run a process? I know how to run a process. I'm doing it on my laptop right now. I just want to run the process on this other machine.
So somebody once said to me, Kubernetes is automated ops. So you imagine you've put something into production, a web scale application, something breaks. So you need to log in, you need to SSH in and restart something, or you need to update a config file. And no, we don't do that anymore because all those tasks are now taken care of by Kubernetes. Is that a statement of truth, or on the black and white spectrum, how grey is that statement?
I don't know if it reflects the reality. So I think it could be considered misleading because you still have bugs in production. You still have people who go onto containers in production and then run a bunch of debug commands because the world still things still go wrong. There's still operational things to do. But Kubernetes enabled people and encouraged people to automate and make operationally stable a lot of things that were formerly ad hoc. So now because we have this separation of build and run, you have to build a container. You know what's running in production. You can actually say this is the code that's running in production. I can remember, and I'm sure you can remember, Jamie, the days when you'd have to go on a server and look at each file to figure out exactly what it was, and even maybe do an MD5 sum to say, is this exactly the same as the one we've got here? That is all kind of taken care of for now. But it doesn't mean you get rid of an ops team. In fact, you still need an ops team. It's just that ops team, because they're dealing with standardized tools and technologies across the stack, they don't have to spend as much time and effort maintaining those things. So if you've got 100 apps running on Kubernetes, you know how they're deployed. You know how to debug them at a basic level. If you have 100 apps deployed across 100 different VMs, then someone has to know about the idiosyncrasies of each of them.
Now, Ian, I always ask questions like this on this podcast. For our less experienced listeners, and that doesn't always mean young people, there might be people our age who are just dipping the toe into the world of cloud native and Kubernetes. What is the best resource for getting started? Do you have a favorite book? Is there a favorite website that you'd recommend, or a Udemy course? How does one begin to write a little application, stick it in a container, and then go through the workflow of popping it onto a Kubernetes cluster?
Oh wow,
How did you start?
that's a great question. Well, I was very lucky. I started because I worked at a bank in 2015 that was among the first to use Kubernetes. So they were actually using OpenShift, which is a kind of distribution of Kubernetes created by Red Hat. They had OpenShift version 2, which was pre Kubernetes, and they rewrote that for version 3, which was version 3 was the Kubernetes based one. And my job was to help them move from version 2 to version 3. So they had these things called cartridges, which were very similar, which were basically the same as containers, but they didn't use Docker.
Right.
And they didn't use the control loops of Kubernetes necessarily. They used other technologies which were around at the time, similar to Google. And so that's how I got to know Kubernetes. How would you learn now?
Well, so there is something Kubernetes.io. There is a
Mhm.
tutorial on there. So do you remember Katacoda?
Yes.
So Katacode, there is an interactive tutorial, and I know something about this because we helped to write them. I don't know if you realise that. The tennis solutions helped to write them, and we did all the graphics for the original Kubernetes tutorial. I'm a
Huh.
little bit flabbergasted to see that I think those images are still ours from our design team. So I guess that's a starting point, following the instructions there, and then you sort of open up the Katacoda interactive tutorial. So for those people who don't know what Katacoda is, it's a type of online learning platform that takes you step by step through the things you're meant to do as you're learning that module.
Yeah, I mean, getting your hands dirty like that is a great way to start. Just running up an EKS platform and just trying to figure it out is another way. If you're more of a self learner, the CKA, the Certified Kubernetes Administrator exams, by far the best exams I've ever taken, in the sense that you have to actually learn the thing to use it. It's not just a case of passing a multiple choice exam.
And they're not easy to pass those exams, is that right?
No, they're not. They're not easy to pass, but because the exam is a very good and practical understanding of what Kubernetes is, the training courses around it are going to be good.
Do you want to hear the most depressing thing ever?
Go
One
on.
of the most depressing things ever. Building container solutions, it's a challenge to scale a business, and you want to do what's true to your heart. And we focused on our onboarding, getting people through the Kubernetes exams, so becoming a certified Kubernetes admin, certified Kubernetes developer. But the problem is, it was better for the business to get the Amazon certificates, the Google certificates, and the Microsoft certificates, because all of our potential enterprise customers would say, yep, they've got all the right cloud provider certificates. But the problem is, those certificates taught us fuck all, and the Kubernetes exams and certificates taught us a lot. So the paradox would be that focusing on the difficult certificates would make us a better consultancy and be able to deliver better value to our customers. But without the social proof of the certificates from the cloud providers, our customers were reluctant to buy. And, when you found a business like I did, you have all these wonderful ideas of how it's going to go, but it never goes like that. And that was a really challenging moment for me, because I don't want our engineers to do nonsense certificates. And I don't want to somehow have a gold sticker that makes people feel good. I
Hmm.
wanted us to be good, not to appear good. And
Yeah,
I remember that being one of the most challenging things. And in the end, it's like, well, if we don't get the broader certificates, then our revenue is going to suffer, and then we don't exist. And all of a sudden, you're into compromising what it is you do in order to make sure that you can secure next year's revenues.
yeah. That is quite depressing, but it's the equivalent of putting a suit on, isn't it? To do some coding. No one wants to do it, but you kind of sometimes you have to.
I've never done it.
No, no, you haven't.
I've never done it. But maybe that explains why my career's been limited by my own stubbornness.
It's probably changed even in the last years. I mean, I was at Barclays. Sorry, I was at I was at a bank 2015 to 2018, I think, and I wore a suit every day. I don't know if they still do.
What do you look like in a suit?
What do I look like in a suit?
Yeah,
Extremely handsome,
I
like
can
unlike what you
imagine.
see before you now.
Yeah, I'd like to see that. Okay, so back to the certificates then. So we think that for those listeners or the viewers, if they're watching on YouTube, that's a good starting point. The Kubernetes certifications and the study paths to get there.
Yes,
Now,
yes,
didn't
exactly.
Kelsey Hightower write something, Learn Kubernetes the Hard Way?
Yes. So when Kubernetes came out, there was a lot. I spent a lot of time building it by hand, which seems crazy now. I mean, it's what, 6 years later, and well, 6 years after EKS came out. I was just looking at this today, actually. 6 years since EKS came out, and but 6 years ago, I was building it on my laptop by hand and fiddling with everything and trying to make it all work, and even dealing with the individual Ansible, because it was originally Ansible that you used to build it on your machine. Anyway,
Right.
Kelsey Hightower produced an open source guide which guided you through building Kubernetes yourself by hand, and
Yes.
that was the hard way. So that it was just a way for you to understand
So
how the different components were built and worked together.
20 years ago, I thought I was quite a normal person. So I didn't understand the HTTP protocol. So I wrote a
Hmm.
web server, right? I thought, well, I'm now
Hmm.
going to interpret the headers and what have you. And then
Hmm.
some of my images went wrong, and I'd encoded them with the wrong character set. Fine. And then when I was working with quite a junior team, Spring had just come out. I really hate, by the way, there's so much Java in this podcast, it's a bit embarrassing. Spring had just come out, and people are like, oh, well, you can disconnect your implementation in real time by changing this config file dependency injection. So, you build an object with a parent class, let's call it, I don't know, human, and then if it had a descendant, a child class, you could pop that in at runtime. Well, first of all, I said that will never happen. There's simply no use case for changing classes in real time, at least not for what we were doing. Second of all, I was like, how does that work? And they didn't know. So I said, no problem, we're going to build a dependency injection framework. And everybody thought I was fucking mad. It took us a day. Of course it took us a day, because it's just a text file and a bunch of stuff. But I said, but now you understand it, now I will allow you to use Spring. At least that part of it. By the way, I hated Spring, but that's a different story. So this doing stuff the hard way is really, really important. I think right now I've got my head in 10 history books about psychology and motivation theory. And I think unless you get the underpinnings, I can't really speak convincingly about it. So I'm a big fan of doing everything the hard way, including Kubernetes.
I think demystifying is such an important part of maturity in software. So anyone who's been in software long enough has had that moment of seeing that there's a man behind the curtain pulling the levers, and it's nothing more clever than that.
Do you know what the thing is? It's fear and anxiety that keeps people away. But if you ignore something, if you don't scratch the surface, you live with a low-level anxiety. As soon as you start to say, right, I'm going to implement a web server, I'm going to write a dependency injection framework, or I'm going to do Kubernetes that way, you've become wiser, potentially weaker, but you grow in confidence. So I think lots of engineers don't fully understand that. It's not always about doing things the hard way just for the sake of understanding. It's also about gaining the confidence to take on larger and larger challenges. To become more risk-seeking, and that's why I like those Kubernetes certificates. And I hated all the dead easy ones from the cloud providers.
I still remember my shock when I thought Jenkins was this tool which magically tested your system in all sorts of amazing ways, and then someone showed it to me, or I looked at it properly, and then I realized, this is just a process that runs and delivers a yay or nay.
It's just a process that runs and looks at an XML file every 30 seconds. I use Cruise, and people would not talk about Cruise for continuous delivery, would not want to look at it. And I was nervous as well. I was like, what is this? What is this shit? So then I took a peek. Okay, so there's a process, and every few seconds it checks if there's been a change in a source repository. If it has, it builds the software and runs the unit tests. Then I started drawing the continuous integration server as a person with a robotic face. So I used to say to people, this is me, this is Fred, this is Ian, and this is the continuous integration server. You see, we're all people. We've all got our own computer. And then what we do is every time, just before we're checking out any changes, we check them all out, run our tests to make sure we've not broken anything, then we check them back in. That's what that fella does, that new robot guy. And then it was totally demystified, but I was scared of it. And I was like, really? Is that it? And then, of course, I made the mistake of coming to the conclusion, well, I could write my own continuous integration software.
Well, it's not that hard, right? I wrote one in Bash just to prove a point.
It's not that hard, and that's where you got Hudson from, and Jenkins, and all the other ones. Okay, Ian, it's time to wrap up. So let me do that by quickly going over the things we've discussed. So we started off by talking about the word origin, Kubernetes, Gubernator, Cybernetics. However, by doing that, we've actually touched upon the importance of a system being stable and then something reacting to changes, the feedback or the cybernetic mechanism. This is almost certainly where Kubernetes got its name from. Then we spoke about orchestras, orchestral maneuvers in the DAC. We talked about orchestrators. Just give us again, Ian, the 30-second spiel. What was the orchestrator? How did we get there?
Oh, Jamie, what are you asking?
I know you've got a bad cold, haven't you?
Yeah, I've got a bad cold. We had containers. How are we going to actually operate them?
Exactly. So it's like now we've got this basic package of deployment package. What do we do with it? And then the final thing we spoke about, or the last thing we talked about, was how can people learn Kubernetes? That became quite an important part of this podcast. There is Kubernetes where you can do some kata coding. There's some tutorials. Kubernetes is the hard way. And I think we're in agreement that doing stuff the hard way is pretty good for your learning process, right?
Yeah.
And on that note, I think that more or less wraps us up. I get the feeling we've only scratched the surface of Kubernetes, but of course there's tons of resources out there, amazing meetups, amazing content, and if this podcast has spurred anybody to go and try further, then I think we've achieved our mission. On that note, Ian, let me say thank you to you.
Thank you.
Thank you, Ian. I've been Jamie, he's been Ian. For all of you going to KubeCon next week, have a great time. Until the next time.
Hopefully see you there as well.
I'll see you there indeed. Bye.
Okay, bye.